Okay, grade 8, how are you again? Today's lesson is Euclidean theorem. This is a new theorem. Maybe we talked about Pythagoras, and this is one of the students of Pythagoras, by the way. This theory also is talking about the right-angled triangle, is dealing with the right-angled triangle. Pythagoras theorem was, or what he discovered, that if you have right-angled triangle, and you want any of the sides of the triangle and you have the other two, you can get it by the sum, the area of the square. This is of course not a square. The area of the square drawn on the hypotenuse is equal to the sum of the two areas of the square drawn on the other two sides. The area of this one, if this one is 25 centimeters square, so and this is 16, this must be 9. Okay, so the square of the area of the square drawn on the hypotenuse is equal to the sum of the other two squares drawn on the other two sides. This is the main idea of Pythagoras. And we said that it is not each time I will draw a square. So instead of drawing a square, I say the area of a square is side square. So I say by other mean way that, for example, AC square y square, because as if I'm getting the area, equal AB square, which is the square drawn on this side, AB square plus BC square, this one. So the area of this one equal the sum of the areas of the other two. This was Pythagoras. Okay, what did Euclidean add to Pythagoras, or what did he discover something else than Pythagoras? Okay, the result of Euclidean theorem is very easy, or the rules of Pythagoras, Euclidean, it is so easy like Pythagoras, but I want you to understand from where this rule comes. Like Pythagoras, in Pythagoras I say AB square equal BC square minus or plus the other side, but as I have explained now, it is coming from the area of the square drawn. Okay, I want now to know what is the idea of Euclidean. In Euclidean theorem, you will find the right angle triangle, and you will find from the right angle triangle there is a perpendicular line segment to the hypotenuse. This is a must. To use Pythagoras theorem, this is a must. Okay, you cannot use Pythagoras while you have a right angle triangle without the line, this line coming from the right angle to the hypotenuse. Okay, what is the rule of Euclidean? Euclidean wants to get AB square. AB, this is one of the two sides. Miss, can I, if I have this one مثلا 5 or 4 and this is 5, Miss, can I want AB, so AB square equals BC square minus AC square. This is according to Pythagoras theorem. Yes, you are right. But I want to get it if, for example, I don't have this one. If I don't have this 4 and I have only the 5, or maybe I will have a BD also, for example 2. So DC will be 3 and all of it is 5. I want to get it. Can you get it by Pythagoras? No. Why? Because if I want to get AB by Pythagoras theorem, I must have the other two sides. What I have here is only one of the sides, so I couldn't use Pythagoras theorem. That's why I'm studying another theorem I can get by using it one of the sides of a right angle triangle by another way, by another given. Some of the exercises you can use both, and you are free to use Pythagoras or to use Euclidean. But another exercises you must use Euclidean, and others you must use Pythagoras. This will be according to the givens. Okay? What is Pythagoras theorem? I want, as I've said, I want to get AB. In Pythagoras theorem, in Euclidean theorem, AB square also, AB square equals what? It is not equal to BC square minus AC square like Pythagoras. It is equal to BD, look, I am talking about this side. So you are taking from the end, you are taking this one. That's why I'm saying AD is a must. This perpendicular line is a must to use Euclidean theorem. It is equal to BD times, without a square, equal to BD times BC all, the length of the hypotenuse. So it is equal to BD times BC. If I want AC square, the same idea. If I want AC square, it is equal to, in this case, I'm stopping at here. It is equal to CD also times the length of the hypotenuse, equal times CB. Without a square, AB and AC is with a square. But you are multiplying two things without a square, not adding and subtracting. You are multiplying. Okay? What about if you want AD square? You want this length, the length of this perpendicular. If you have AB and BD, you can get it by Pythagoras. Sorry, I don't know what's happening. Okay, sorry. Okay. If I want AD square, the length of this perpendicular, if you have AB or BD, AB and BD, you can get by Pythagoras. If you have AC and CD, you can get it by Pythagoras. If you don't have and you only have these two small parts, AD square equal to BD times BC, not all the hypotenuse. So the two sides of the right angle can come by multiplying the length of this small part times the length of the hypotenuse, or the other side, which is AC, the length of the small part from this side times the length of the hypotenuse. If you want the length of the perpendicular line, it is BD times DC. Okay? Okay, these are the three rules of Euclidean. Okay, from where I got this rule? Why AB square equal BD times BC? This is for your info. You will not use it. You will use the rules I have just said. These are the three rules. Okay, but I want you to understand from where. Euclidean theorem says that in the right angle triangle, the area of the square drawn, what I'm getting one of the two sides. The area of the square drawn, the area of this square, that's why it is AB square. The area of the square equals what? If I'm reading the theory, the area of the square on a side of the right angle triangle, this one, equal to what? In Pythagoras, it is equal to BC square minus AC square. In this case, it is equal to the area of a rectangle. Rectangle? Yes, that's why it is two sides times each other. There is no square. There is no square like Pythagoras. Okay? And if I'm getting the area of any figure, I'm not doing a square. If I want the area, it is length times width. Okay, where is the length? He is saying that the area of the square drawn on one side of the right angle triangle equal to the area of a rectangle. Which rectangle? Where are the dimensions? The rectangle which is talking about it, which is equal to the area of the square, is, its dimension is the length of the projection of this side on the hypotenuse. Where is the projection if I remove this one? Do you remember the projection? Where is the projection? Projection, we said that if I have a line and I want to get its projection on another line, I will drop the perpendicular distance. So here I am talking about AB. He's saying that the area of the square drawn on AB or on one side of the right angle triangle equal area to of the rectangle, which dimensions is, I'm talking now about the length and the width of the rectangle. Its length, or one of the dimensions, is the length of the projection of AB on the hypotenuse. This is the hypotenuse. Let's get the projection of AB. B, the point itself, because it's on the line. The length of the projection of the point A is point D. That's why the projection of AB on L or on the hypotenuse is BD. So the area of the square drawn on one of the sides equal the area of the rectangle, which dimensions is the length of the projection, AB square. This is the area of the square. The length of the rectangle is BD. He said it is equal to the length of the projection of this side on the hypotenuse. And what is the width of the rectangle? And the length of the hypotenuse itself times BC, the length of the hypotenuse. Is it clear? Okay, going to the other side, the same. The length or the area of the square drawn on the side of a right angle triangle. The area means AC square, equal the area of the rectangle. Its dimensions are the length of the projection. Where is the projection of AC on the hypotenuse? This is the hypotenuse. The projection is C, the point itself. The projection of A is the point D. So the length of the projection CD times the length of the hypotenuse itself. Where is the hypotenuse? The hypotenuse is CB. So times CB. That's why this is a square, this is not a square, because this is area of rectangle, length time width, and this is area of a square. This is Euclidean theorem. Okay? Okay. Let's go to some exercises. Here, practice. DEF is a right angle triangle at D. DN is perpendicular on EF. EN equal 9. And look, NF equals 16. This part 9 and this part 16. So the whole hypotenuse is 25. Okay? Let's complete. He wanted DE square. Again, revising. DE square equal what? Equal the length of the projection. Or we will not say the theorem in each time. I must know the rule or the how to use the rule. It is equal to EN square times the length of the whole hypotenuse. So it is equal to 9 times 25. So 9 times 25, it is equal to 125. But don't forget that I must put it under root. So it will be 15 centimeter. So the length of DE equal 15. I want DF. Miss, I can get DF by Pythagoras. Yes, you can. In this case, yes, you can. In the first one, DE, you couldn't get it by Pythagoras because you have only the length of EF. You don't have DF. But in this case, now you have two sides. You have DE 15 and EF 25. You can get it by subtracting 15 square from 25 square. But here he wants you to use Euclidean. He told you that DF square equal what? Equal Fn times what? Times the length of the hypotenuse. So it is equal Fn times Fe, which is 16 times 25. So 25 times 16 equals 400. 400 under root equal 20 centimeter. So this is 15, this is 20. At the end, he wanted dn square. dn, you can get it from this triangle by Pythagoras, 15 square minus 9 square, or by this triangle, 20 square minus 16 square, or by using Euclidean, and that is what he wants. He wants you to use Euclidean. dn square, don't forget that it is en times nf. So it is Euclidean theorem, because he's writing ne times nf. 16 times 9 equals 144, which is 12 under root. There is an important fact in math or rule. I can also get the length, and this is important. I can get the length of AD without a square, and without putting the result under root when you finish. You can get AD by multiplying the length of the two sides of the right angle, which are AB times AC, divide the hypotenuse. Okay, this is another rule to get AD. Don't forget, this is without a square, but this is with a square. Okay, okay, this is very important rule as well. Okay, so in this case, you can get dn square by multiplying ne times nf, or by multiplying de 15 times df 20 divide by 25. You will have the same result. When you multiply 15 times 20, then divided by 25, you will find it is equal to 12 also. This is an exercise. I want ABC as a triangle in which ABC equal 90 and BD equal 90, or BD is perpendicular on AC. The whole length of AC is 5, AB 4, first you want BC. Can you get BC by Euclidean or by Pythagoras? Okay, if I want to use, as we are talking about Euclidean, I want to use Euclidean, so BC square equal what? Don't go from C. It is equal to CD times CA. Do you have CD? No. You have only CA, so you cannot use Euclidean at this time. So I will use what? Pythagoras, because I have the length of the other two sides. Pythagoras says BC square equal AC square minus AB square equal 9, 9 under root equals 3. What about, so this is 1, 3. AD. Okay. One of you will say, Miss, I will get BD first. When I'm getting BD, I can get by Pythagoras, I can get AD. That is right. BD, you can get it, you cannot get it by the rule CD times DA, because also you cannot divide it 2 and 3, 1 and 4. You must know it from the givens. Okay, it is all 5. This one, it is not a ratio 2 to 1 or 1 to 2 or 1 to 3. So we cannot say that this is 1 and this is 4, or this is 2 and this is 3. So I will wait till I find something to tell me what is DC and what is DA. So I can get DB by the rule I have just said it to you, by multiplying the two sides, 3 times 4, divide the hypotenuse, which is 5. So DB will be 12 divided by 5 equals 2.4. So this is what, this is the DB. From DB you can get AD square from Pythagoras. AD square, this is a side, equal the length of the hypotenuse minus, sorry, I want AD square, so it is 4 square minus 2.4 square. So it is 16 minus 2.4 square. It will be equal 256 divided by 256 by decimal. I will get it by decimal. Okay, you can get it because I didn't calculate it by this way now. Okay, so you can get it, or I want you to use in one step, in order not to do all that steps, you can use Euclidean. How? Yes, I can use Euclidean. AD is a part of what? Part from which rule? AD is a part when I'm getting AB square. You remember, if I want AB square, what is the rule to get AB square from Euclidean? If I want one of the sides of the right angle, it is equal the length of the projection, which is AD, times AC. It is equal to AD times AC. Substitute AB equal 4. 4 square, 16. AD, I want it. AC given 5. So AD equals 16 divided by 5 equals the 3.2. So AD equals 16 divided by 5 equals 3.2 centimeter. So AD equals 3.2. Okay, so this part 3.2. Now I can get طبعا DC 5 minus 3.2 equals 1.8. So the small part, which is CD, is 1.8. Now he wants BD. I can get BD by the rule AB times BC divide AC, or by Euclidean BD square equal 1.8 times 3.2 equals 12 over 5 under root, so it is equal to 2.4. So this BD equals 2.4. Did the same answer I have got it from the other rule. So DB equals 2.4 and AD we said it is 3.2. He want what? He want the area of triangle DBC. What is the area of the triangle? Half base time height. Where is the base? The base equal 1.8, the height 2.4, and you will calculate it to get the result. The last example in our lesson today, as you see here, I have many right angled triangle. I have maybe 3. ABC is a quadrilateral. BC 7, CD 24, AB 15, and there is an important given here, AE perpendicular on BD, which is very important to use Euclidean. Without this given, you couldn't use it. By the way, when I'm writing, you remember when I want to start to talk about Pythagoras, I must start with sense, measure of angle. Any angle equal 90. Then, therefore, AB square equal DC square, Pythagoras. In Euclidean, if I want to start and prove by Euclidean, you must say that since measure of angle, for example, like this one, A equal 90, and AE perpendicular on BD, this is a must to be written, because without this perpendicular, you couldn't use Euclidean. Okay? Okay. But here, that's I'm not writing proof as a proof. I'm just explaining. First, I want the length of BD. Where is BD? BD. Look at the BCD, triangle BCD. Of course, I have 2 sides. It's very easy to get it by Pythagoras. BD square will be equal, this is the hypotenuse, so equal the sum of the other 2 sides, which is BC square plus CD square. So it will be equal 27 square 49 plus 24 square 576. So it will be equal 625. 625 under root, it will be 25. So the length of BD 25 from Pythagoras, a normal way. AD, next one, he want AD. Look at the triangle up, ADB. Also, now I have BD 25, BA 15. I can get it by Pythagoras, but here by subtracting. So it will be 625 minus 15 square, which is 225, equal 400. 400 under root, so this is 20. So now I got BD 25, AD equal 20. Okay, so this is 20 centimeters and this is 25 centimeters. What about the next one? He wants me to get the length of the projection. Remember the projection. He didn't say the length, the side like the A. He wants the length of the projection of AB. Let's start to see where is AB. This is AB. The length of the projection. Not, he didn't want AB. AB aslan 15. The length of the projection of AB on what? On BD. Please make your line very clear to get the projection. Each point alone. Projection of B is the same point. Why it is the same point? Because B lies on the line he wants me to get the projection on it. B and B. A. I want the projection of A, so I will go perpendicular. So the projection of A on BD is the point E. So he wants what? He wants BE. This is the length he wanted. How can you get BE? By Euclidean or by Pythagoras? If you got, like the previous example, If you got AE from AB times AD divide DB, you can get it, this small part, you can get it by Pythagoras also. If you don't want to use this two steps, you can get it by one step from Euclidean. Let's write Euclidean. If I want AB square, if I want this one, AB square, the rule is what? The rule is BE times the length of the hypotenuse. So it is equal to BE times BD. You have AB 15 square. I want BE. BE, where is BE? The length of the projection of AB on BD is BE times BD, which is 25. 225 equal BE times 25 by dividing 225 by 25 equals 9. So BE equal 9 centimeters. So you got BE 9. So let's remove all of this. This is 9. Don't forget that the whole length of BD was 25 and this was 20. What else? The last thing he want the length of the projection of AD. Where is AD? Excellent. This is AD. Where is the line? On what? On BD also? No, not on BD. He wanted on AE. Where is AE? Yes, mark your line. This is AE. The length of the projection of, this is A. The length of the projection of AD. Tab A lies on the same point, so it remains as it is. D, go perpendicular to the line, the purple one. So it is E. So he wants the length of what? He wants the length of AE. I can get AE by two different ways. Maybe AE, if I use Euclidean, AE square equals what? Equal BE times ED, not 25. 25, this is the whole hypotenuse. The 25 minus 9, it will give you 16. So this part is 16 because I got BE 9. So the rest is 16. So it is equal to BE times ED, which is 9 times 16. 9 times 16 equals 144. So the length of AE equal root 144 equal 12. Can I try the other way? Yes, you can. What is the other fact I told you? It is a fact. AE without a square equal the two sides of the right angle triangle divide the hypotenuse. So it is equal 15 times 20 divide the whole hypotenuse 25. So 15 times 20 divide 25. It is also equals to 12. Okay? Is it clear? I wish that you understand this lesson, and see you next time with our last lesson in our curriculum in grade 8 or in the geometry of grade 8. Wish you all the best and miss you so much.